Findas algorithm.
Findas algorithm. So for that algorithm, we'll be executing the first lab program. Okay. So in which programming language we can execute this? In which programming language you can execute this program? Assignments will be given from today onwards for the lab. Okay. And I want you to complete it within the next lab session. For that, marks will be evaluated. Okay. Good afternoon, everyone. Avan, video off ಮಾಡು. Hello. Log in through only audio call. Okay. Don't switch on to your video mode. Okay. So today we will discuss about the first lab program. So you can use either Python language or Java language. You can choose any one. Okay, but we will be using it majorly as Python because the length of the program and the inbuilt functions are very much used in the Python. So it's very easy for us. So let's start with the first lab program. So the first lab program, what it states that implement and demonstrate a Findas algorithm for finding the most specific hypothesis based on the given set of training data samples and read the training data from a CSV file. So here I need to execute my Findas algorithm. I need to find out specific hypothesis for the given data set. And also I need to read the training data from a CSV file. So these are the first three conditions. Okay. So what does our algorithm state? In the last class we had discussed. So initialize the hypothesis to the most specific hypothesis. In general, it will be null state. Okay, all the data will be attributes will be empty. So what I will do, second condition, for each positive training instance, I need to check the attribute constraint in the hypothesis. If it satisfies the instance, then we should do nothing. If the constraint doesn't satisfy, then I should modify my hypothesis to the next more general constraint that satisfies the instance X. Okay. At last, I need to trace all the training examples, and then at last I need to obtain my specific output hypothesis H. Okay. So here in this example, we have taken the lab theory example itself. So training example. So example numbers. So the attributes, and the last attribute is my training attribute, or the based on the training target function, the enjoy sport, I will be evaluating the whether the person can enjoy the sport or not. Okay. First, I will show you how the program need to be executed. How many of you have worked on Anaconda Spider platform? So you know how to run, right? There are different options here. Run, you can directly run the file automatically, or if you want to check line by line execution, at that time you need to go for run selection or current line execution. Okay. So you can use both these two options. So let us first execute out and see the output. So when I run this file, so in the right hand side in my console window, I got the output saying that the running file is in the particular path and the working directory of my program, where it is. Okay. Next, I have read the data of the attributes that are present in the file, and it is not in the table format. Okay, it's in the file, it is in table format, but here it is automatically read as a attribute value. That's it, by comma separated value CSV file. So how many instances are there? 1, 2, 3, 4. So it's going to print the total number of instances first. Okay. Next, what I should do? I should initially the hypothesis should be made as what most specific, but I have not yet read any data. So at that time what happens? All the data set will be in the form of null, but it should be done automatically. You should not give the value by default. Okay. Next, so what is my first hypothesis? The hypothesis for the first training instance is, so initially it is empty. So it's going to read the first instance. When it compares with the null, so what happens? I get the first instance automatically. So this year we have discussed in the theory class also in the yesterday's class. So then what happens? It then compares with the hypothesis generated, first hypothesis, to the second instance of the training data set. If the values get changed, then automatically it will be made as specific. Like in the second instance, you can see here, the second instance is sunny, warm, high, strong, warm, same. Whereas in the second hypothesis, I'm getting sunny, warm. The third one is question mark, because the temperature value is getting changed from normal to temperature or high. Whereas the next three attributes remains the same. Okay. So that is my second hypothesis. Next, what I will do, I will compare this with the third hypothesis, but I need not to compare this. Why? Because it's the target function's value is negative. Example. So what happens? I need not to check the hypothesis for it. Directly, I can skip this third instance. Okay. So what happens? The third instance remains the same with respect to the second hypothesis. Okay. Next. Now I will compare the third hypothesis with the fourth instance. So sunny, warm. So I'm already having the third attribute, that is humidity, as high, as specific. So I need not to change it. Next, whereas my wind attribute also remains same, strong and strong. Whereas the last two attributes, water and forecast, are getting changed. Right? Earlier it was same, now it is changed. Earlier it was warm, here now it is cool. Okay. So at that time, I get the last hypothesis as this hypothesis. So the obtained final hypothesis will be my maximum specific hypothesis, which will be the last trained hypothesis. Do you have any doubt in the output section part? Because I will be giving assignments by making teams with different data sets. I need you all to execute it and submit the data within the next lab session, next lab. Okay. So now, so what I should do? So let us come to the first programming part. And the length of the program is very much less. Okay, without using any inbuilt function. So what is my first line? I need to read the data from what? CSV file, right? So hence I'll be importing the CSV feature. Okay. Next, what I'm doing, I'm taking the list to an array name A or a variable A with the empty data. Okay. Why I'm taking empty data means because I'm going to read the data from the file. Hence, the list will be empty in the initial stage. So what I will do, next condition is with open. So I feed the data from the file, right? I have mentioned the CSV file, but I have not mentioned the path of the file here. Why? Because this file is present in the same folder. So I need not to generate the path of the directory here. Okay, no need to enter the path of the directory file here because this file remains in the same folder where I am executing. So what I will do, I will take the permission of the file as read r as CSV file. So you know the rules and regulations, right? After the command, I need to give indentation 4 space. So for each row in my CSV.reader of the CSV file, what I should do, I should append the data as the which data, row data, right? So I'm using the command as a.append. This is the method. Read the array or the variable a dot append of row data to be printed in the output. So that is what this is. This is the output for this line, this print here. Okay. Next, what I should do, I should print the total number of training instances. So for that, print / the total number of training instances. It calculates the length of the row values. So length of A. Okay. Next, what I should do now, you can see it. I will show you the file. So this is my file. Okay. But how many attributes I'm having here? Column 1, 2, 3, 4, 5, 6, 7. Do I need to check all the 7 attributes? No, right? Because I will be checking only the first 6 attributes. So what I will do, I need to calculate the number of attributes. For that, the number of attributes is equal to length of A of 0 minus 1. So what it gives A of 0 means it goes to the Excel file. This is my A of 0. How many attributes I'm having? Total 7. 7 minus 1, 6. So the number of attributes that needs to be trained is 6. Okay. Then I'm giving the print statement empty data. Next, with a new line, I'm initializing the hypothesis. So the initial hypothesis will be how much? It should not be default, right? Based on the attributes, I need to multiply it with null set, null data value, specific one. So at that time, hypothesis is equal to, in the list, I'll be taking the null as 0 into number of attributes. How many attributes I'm having? 6. So the output is, I'm having 6 initial hypothesis. It is specific. I'm printing this hypothesis. Got it? Now comes the main part of the program. So this is my logic of the code. So I'll be taking for loop in range. I'm using the inbuilt function range of 0 comma length of A. So what is the length of A? 6. So I need to read the data from 0 to 6. That is the column data here. 0, 1, 2, 3, 4, 5. That's it. I need not to check this data because this is my target function. Okay. So I'm comparing if A of I, what is I value now in the initial, it is 0, A of 0 into number of attribute is 6. I'm checking, I have told you in the theory class, I will be checking only the target function. If it is yes, I need not to do any modification. I need to generate the hypothesis for that. If it is no, I need to skip that. Okay. So what I will do, A of 0 into comma 6. So this is my A function, A of 0, the sixth value is this one. What it is, yes, right? And it is represented in small letter here in the file. Here also you should use the same type of name here. Or else you'll be getting an error. If you use capital Y over the file and you are comparing it with a small y here, at that time the file won't be read, or you may not get the exact correct output. Okay. So that is what this line states. If A of I 0 to 6 attribute is yes, is it true? Yes. So what I will do, I'll compare with the next one. For J in range of 0 of number of attributes. So what is the J value right now? 0. Number of attribute is 6. So I need to compare the value from 0 to 6 attribute. So I'll be checking the condition now. If hypothesis is of J, hypothesis of 0 is equal to 0 in the initial state? Yes. In the initial it is 0. So 0 equal to 0, true. Or sometimes if the value is not 0, what I should do? I should read the values that is specified in a particular column. How I need to get that data? So hypothesis of j is double equal to a of I comma j. So when some at that time what happens? This value will be read. A of I means a of 0 comma j. J is also 0. So it will be read the first value from my file. Okay. So that comes here, and then I will read that data and I replace it in the hypothesis of the 0th column. So that is what here it is, the first instance. Before that, I need to replace it in the memory. So what happens? So this condition holds good. So now what happens? It goes for the next value. So that is nothing but next column data, that is 0 I have finished. So the next value is 1. The j becomes 1. So a value is 0. So 0 and compare it with the 1. So does it has? Yes, yes. Next, it replaces the data and compares with the initial hypothesis and replaces it with the specific hypothesis. So this condition executes until the range 0 to 5. For the fifth attribute, that is 0, 1, 2, 3, 4, 5 is replaced. When the range becomes 6 and the length of the attribute is 6, at that time the value gets not a true condition, so it skips from the condition. So this is for the single hypothesis. Similarly, the program execution takes place for the next hypothesis when the value of I becomes 1 here. I equal to 1, then j is equal to 0. Okay. So likewise, it reads all the data. So this is for the second condition. What happens? So sunny is compared, no need to change. Warm and warm will be compared, no need to change. So the next normal and high will be compared. So it is the values are just changing. So I am going to make it as question mark here in the second hypothesis. Next, strong and strong will be compared. There is no change. Warm and warm, no change. Same, no change. So it retains the same 3 values as it is. Now the target function is yes. Now what happens? In the second hypothesis, I got this hypothesis. Okay. Now I'll be comparing this hypothesis with the next instance. So at that time, what happens? I need to check the attribute of my target function. So a of 0 is I value is now right now 2. Number of attribute is 6. So a of 2 comma 6. A of 2 means this value, second row. So here 1, 2, 3 is not considered. It starts from 0 now in our memory. So 0, 1, 2 of 6. What is the sixth value, sixth column value? No. So what happens now? The value is not true here. So I am getting no equal to yes. So this condition gets failed. So I need not to execute this part. So I'll be directly going to the else part. In the else part, what I will do? I will replace the hypothesis by question. But I need not to do that because this has already been done for the hypothesis already. If this condition works in the initial state, okay, or in the specific hypothesis. So what happens now? It skips this condition and it increases the value of I, so it becomes 3. So a of 3 of number of attribute is 6. So a of 3 comma 6 means a of 3 value at the column name is 6. So what it is I am having? Yes. So it compares. So yes equal to yes, true. Similarly, the j will be incremented by 0 to 5 and it prints the hypothesis like this, because you can see here I have got this instance as this value, but new warm question mark strong warm same. I need to compare with this. What happens? You can see here sunny will be compared with sunny. So what I will get? I will get it as sunny. Next, comma. Warm will be compared with the second column of my instance warm. So it is same. I will be replacing it as same. Next. So question mark is already, it means the third attribute is already specific. So it doesn't matter whether my next instance is having high or low. So automatically it becomes question mark. Next, I'm having fourth attribute as strong. In the fourth instance, I'm having strong. So it remains same as it is. Okay. Next, I'm having what, whereas here I'm having cool. So the values are getting changed. So what I should do, I should make it as specific question mark, comma. So the last instance I'm having same forecast, whereas here I'm having change. So the values are getting changed from same to change. So what I should do, I should make it as specific. So this is the last hypothesis. What it is, Sunny, warm, question mark, strong, question mark, question mark. So this output should be the final hypothesis for my training example. Okay, let us see that. So I'm having this. Okay, once this loop condition gets failed, so what I should do, I should print my maximum specific hypothesis for the training example is print hypothesis data. So I'll be getting the maximum specific hypothesis like this. Got it? So this is your first lab program. Do you have any doubt in this? This is a very simple one. Okay. And it need not, listen one more thing, I need not use directly use the short form for here, h of j, but the same name should be used in your whole program. Okay, that's the only thing you need to remember. And whenever I giving the data values or reading the data from the trained function, the trained function's data should be matched with respect to the file. If you are using capital S over there, here also you need to compare it with capital S, or else you'll be getting error. Okay. Do you have any doubt in this? Hello? Hello? Anjana? Nivedita?
Yes, sir.
What? Suppose if I want to check the value of the negative examples, what changes I should do in this program? So what I should do, I should check for the negative example, right? At that time, I need to replace it by yes by no. But this data should be matched with my file. Yes, it is there. So I will close this file and I'm going to remove this data. So whenever I do modifications to the file, what I should do, I should close the file. Now I should run it once again. Save, execute it. So what I'm getting, what is the output? You can see here. The initial hypothesis is 0. The hypothesis for the training instance is 0. Why? Because it is comparing only the no attribute. So the first Enjoy Sport game is having what? Yes. Second training instance is also yes. So only when it compares with the third target instance, no, it replaces these values by a specific hypothesis by question mark. So that is what it's here. See, the second hypothesis is also null because it is yes. Whereas the third one, it is no. So it checks the condition, this condition. So the maximum hypothesis for negative instance is the same. Got it? But it should be yes for the find algorithm because we are need finder's drawback is we are not going to check the negative example. Okay. If you have any doubt, suppose if I want to print the number of attributes, so what I can do, I can directly print the data in the console. See, length of a of 0 is equal to 7. So this is what it is. 0, 1, 2, 3, 4, 5, 6, 7. You can easily check the data here. Okay. Do you have any other doubts? Because assignment will be given, and once it is given, you should never ask the doubts. If you have any doubts right now, you can ask me. Okay, this is what your first algorithm and first lab program. Okay, and I'll be sending this program file, CSV file and Python code. Okay, try to execute it in your system. An assignment will be given for that. I hope you all got the concept right. If you have any other doubts, you can ask me now. Anjana and Christian, Bhavani, Akshita, Lucky, Megha, Sahil, Navya, Rachana, Rahul, Rakshita, Ruchita, Rajiv, Safana, Sahana, Sarika, Shweta, Neha, Srinivas, Yashaswini. Okay, that's it for the today's class lab session. Okay, so see here. In the else part, it gets executed only when the attribute is no. Okay. See here, I am reading the data as yes, right? Suppose if I had explained it right now, right, by comparing it with the value of no, right? So when I make the attribute to be compared with the no, what happens? The initial hypothesis is 0. So I am not going to check with the first training instance of my target function because it is yes. So what happens? I need not to compare, execute this part. So because what happens? This A, if A of I of number of attribute is no, so that means no equal to yes, whether it is condition is true or false, false. So if for 0 means it skips this part and it comes to the hypothesis one. Okay, so it has to be made as specific. Got it? That is for when it is a negative example. Or else you can skip you can write another for loop for comparing it with the negative training example in the same hypothesis. The same logic, take one more for loop and the same thing, but compare it with the no condition here. This hypothesis will be compared when it is 0. If it's already having the value, no need to compare, it will be automatically taken here. It will be matched with the here normal it is there, the third one, but when I compare with my data, it is high in the second instance. So what I will do, I will make it as question mark. Got it? So if you have any other doubts, you can ask me, or if we will wind up the lab session class. It's a very simple program, okay? And right now I'll be sending the assignments for each one of you. And the team remains the same until for the whole semester. Make a group of 5 making 5 students. So you need to download the data set from the things where I'm specifying. So for that data set, you need to apply the finders algorithm concept. Okay, but you can take any other attributes. It need not to be the enjoy sport. Okay, you can consider any other attributes. At least minimum you need to compare the data with 15 into 16 rows of data, 20 rows of data. Okay, from the original data set. You need to extract that, compare it with the train, and then test with it as different example. Okay, that's it. Have a nice day. I'll be sending the assignment, compare, execute it, and then I need you all to submit the assignments within the next class session. Okay, thank you. And if you don't have any other If you don't have the properties for to install the software, you can go for Anaconda online or for Spider online framework. This is the I'll be sending the link that for that one also. Okay, you can do that in online mode also. Apart from this, if you have any other doubts, you can ask. And I need you all to do changes for this program by comparing it with the or by executing using libraries. Okay, you can use either TensorFlow libraries or you can use Panda libraries or you can use Seaborn libraries. Okay, or else you can go with the scikit-learn library, inbuilt library functions. You can use any other libraries, but I want you to automate this from the program in using library functions. Okay, so that will be also one of the assignment for each one. That's it.